They take the biopsy and they do these incredibly painstaking processes where they, under a microscope, they actually tease apart the muscle fibers and they take out all the other stuff. And then what they do is they take those muscle fibers and they use them for their analysis. And when you do those precise measures, the variability between people comes down and the effect size that we see with the endurance and strength goes up. And so I think that a lot of what we see in places where we don't see an effect is because it's a little bit too crude a measure. And so you can see these effects, but scientifically the studies are very, very difficult to do.
So the more you move away from the muscle level, the micro level, the more crude the measures are to determine some kind of concurrent training effects. And that's why the research is a bit blurry when it comes to humans.
Muscle is a tissue with more than 10 cell types in it. So if you just take a big clump of muscle and you break it down, what you're going to have is you're going to have vascular cells, nerve cells. You're going to have immune cells. You're going to have these stem cells. You've got all of those different cells, and each one is maybe doing a different thing. So when the Blumstrand group goes in and separates them, and Will Apro does this, and he's got students who do this, separate out the myofibers, take out all of those other cell types. The myofibers, their response is relatively uniform. When we just take a big group of muscle includes these other 10 cell types. Now those other 10 cell types that are also responding to the exercise in different ways, that's going to make the signal that we get from those more crude analyses more difficult to get a clean signal from.